we have discussed Hermitian operators and Hermitian adjoint. Now we will see some problems to clarify the concept of Hermitian operators and Hermitian adjoint. So let us see the first problem. We have to test that there is an operator H hat defined in this manner, and we have to test if this operator H hat is Hermitian or not. So see the problem and follow the rules and tricks which in previous lecture I have told you, and following that tricks you can easily test the given operator is Hermitian or not. So first of all, what we will do? We will do that we must find the Hermitian adjoint of the given operator, and if the Hermitian adjoint of the given operator will be equal to the given operator, then this will be Hermitian. So we can say that H hat is Hermitian. We know Hermitian operators are self-adjoint, so H hat is Hermitian if the Hermitian adjoint H hat dagger is equal to H hat. If this condition will be satisfied, then you can say that the given operator is Hermitian. So let us find the Hermitian adjoint of the given operator. So now H hat dagger, that is Hermitian adjoint of H hat. As we have studied that A hat plus B hat dagger is equal to A hat dagger plus B hat dagger, and the number of operators may be more than 2, and the same rule will be followed. So following this particular rule, what we can write it? We can write it as this will be Ket phi 1 Bra phi 1 dagger plus Ket phi 2 Bra phi 2 dagger plus Ket phi 3 Bra phi 3 dagger, and minus I Ket phi 1 Bra phi 2 dagger minus Ket phi 1 Bra phi 3 dagger plus I Ket phi 2 Bra phi 1 dagger, and minus Ket phi 3 Bra phi 1 dagger. And now follow the rules which we have learned in previous lectures. We know that whenever there is a product of two operators and we have to find the Hermitian adjoint, then the result is like this. The order of the operator is just reversed, and of each operator we take the Hermitian adjoint. Here both operators are in fact same, so the result will remain same. So this will be Ket phi 1 Bra phi 1. Plus, this is also like the first term, so this will be Ket phi 2 Bra phi 2. This is also same as the first and second term, so this is plus Ket phi 3 Bra phi 3 and minus. Now here I is a constant term, and we have learnt that when there is a constant factor we should take its conjugate. So conjugate of I will be minus I, and so here will be plus, and Bra is replaced by Ket and Ket is replaced by Bra. So there will be I Ket phi 2 times Bra phi 1. We are just following the rules. And now minus here there will be phi, Bra phi 3 will become Ket phi 3. This will be Ket phi 3 and Bra phi 1. And we will take the complex conjugate of I, and that will be minus I and interchange the Bra and Ket by corresponding Kets and Bras. So this will be Bra phi 1 and this will be Ket phi 1. This is Ket phi 1 and Bra phi 2. And here will be minus Ket phi 3 and Ket phi 1 and Bra phi 3. Now see this result and compare it with the given operator. So our given operator is what? See, this is this much, and if you will compare the value of h hat with h hat dagger, then you can see this is same as that of h hat, and therefore what is our result? Our result is h hat dagger is equal to h hat, and if this condition is satisfied, what it refers? It refers that h hat is Hermitian. So the given operator is a Hermitian operator. You have seen that very easily, remembering the important facts which we have learnt in previous lectures, we can solve such types of problems. Now let us take a simple example. This is, we have to show that the Hermitian adjoint of the operator IA is minus IA dagger. This is a very simple problem. Following the rules, we can easily solve it. Let us suppose the given operator is B hat. It means we suppose that B hat equal to IA hat. Now we have to find the Hermitian adjoint of this operator B hat. So its Hermitian adjoint is written as B hat dagger, and what will be this? This will be IA hat dagger, and we know this is a constant factor I, so we should take its complex conjugate, and its complex conjugate will be what? This will be minus I, and the operator is changed by its Hermitian adjoint. So this will be minus IA hat dagger. So we can see that, remembering the important rules, we can easily solve this type of problems. Now let us take a third example. Discuss the hermeticity of the operators number 1, A hat plus A hat dagger. Number 2, I A hat plus A hat dagger. And number 3, this is I A hat minus a hat dagger. We have to test the hermeticity of these operators. It means we have to find that these operators are Hermitian or not. So let us solve this problem. Number 1. If we have to test its hermeticity, what we will do? We will actually find the Hermitian adjoint. And if that Hermitian adjoint is same as that of the given operator, we can say that the given operator is Hermitian. And if it is not same, then it is not Hermitian. So let B hat equal to A hat plus A hat dagger. We consider it. Now we will find the Hermitian adjoint of B hat. This will be equal to what? This will be A hat plus A hat dagger. Now we know from the property of Hermitian adjoint, this will be A hat dagger plus A hat dagger. And what will be this? This is in fact A hat and plus A hat dagger. So what we see? We see that this is equal to simply B hat. And so this operator is Hermitian. So it is Hermitian because its Hermitian adjoint is same as the given operator. So this is Hermitian. Now we will test the hermeticity of the operator given in number 2. Here in number 2 we consider again B hat equal to I A hat plus A hat dagger. Now we will again find the Hermitian adjoint of this operator B hat. So this will be what? This will be I A hat plus A hat dagger. Now follow the rules. We have to take its complex conjugate, that will be minus I, and here this will be A hat dagger plus A hat dagger. And what will be this? This is minus I. See here, this will be what? This is A hat and plus A hat dagger. Now we know that this I times A hat plus A hat dagger is B hat. So this is minus B hat. B dagger is equal to minus B hat, and it means B hat dagger is not a hat, minus B hat. And since B hat dagger is not equal to B hat, so the given operator is not Hermitian but anti-Hermitian or skew Hermitian. So I A hat plus A hat dagger is not Hermitian. Hermitian. It is anti-Hermitian. It is anti-Hermitian. Now we will test the hermeticity of the operator given in number 3. What is this operator? This is I A hat minus A hat dagger. So again we let B hat is equal to I A hat minus A hat dagger. So to test its hermeticity, we will find the Hermitian adjoint of B hat. And what will be this? This will be again I A hat minus A hat dagger. And following the rules, this will be minus I A hat dagger minus A hat dagger. And this is minus I. This will be A hat. So this is A hat minus A hat dagger. And we can write it. This will be plus, because this will be A hat with minus sign and this is with plus sign. So we will take out the minus sign common. And what we see? We see that this is simply B hat. Therefore, B hat dagger is equal to B hat. And this property implies that B hat equal to I A hat minus A hat dagger is Hermitian. So you can see, following the rules we have learned, we can easily solve this type of problems. Now let us take another example to clarify our concept. We will take a very important another example. So this is example number 4. Find the Hermitian adjoint of f of A hat. This is a function operator actually. And this is equal to 1 plus I A hat plus 3 A hat square times 1 minus 2 I A hat minus 9a hat square and divided by 5 plus 7a hat. We have to find the Hermitian adjoint of this given operator function. Since the Hermitian adjoint of an operator function, how we define as? Since the Hermitian adjoint of an operator function f of a is given as f dagger a hat is equal to f star, this is complex conjugate of f, a hat dagger. So we can write this is the given operator function and we have to find its Hermitian adjoint. So what we will write? We will write it as 1 plus ia hat plus 3a hat square times 1 minus 2ia hat minus 9a hat square over 5 plus 7a hat dagger, and this will be equal to what? First of all, see here one thing. When we find the Hermitian adjoint of product of two operators, then we just reverse the order and take the Hermitian adjoint of each and every term separately. So following that rule, we can write this will be equal to what? So this will be 1 is real, so this will remain same, and there is minus 2i, and we should take the complex conjugate of I, so that will be plus 2i and a hat dagger. Then the term is minus 9a hat square, and we know when there is a hat dagger to the power n, this is equal to a hat dagger n. So this will be what? Minus 9 a hat dagger square. And times, now we'll take the Hermitian adjoint of first term. This will be 1 there is plus I, so that will be minus I a hat dagger, and then is 3a hat square, that will be plus 3a hat dagger square, and over 5 plus 7 a hat dagger. And in fact, this is the Hermitian adjoint of the given operator function. Now let us take a last example. We have to show that the expectation value of Hermitian operator is real, and that of an anti-Hermitian operator is imaginary. We will solve this problem, but this is a very important fact, so we must remember such a fact. So we will remember it too. We have to prove that the expectation value of Hermitian operator is real and the expectation value of anti-Hermitian operator is imaginary. We have to show this. So to solve this problem, let us consider a Hermitian operator. Let us say A. So this is our solution. Let A hat be a Hermitian operator. We suppose that A is a Hermitian operator. Then, if A is a Hermitian operator, we know that this operator is same as that of its Hermitian adjoint. So A hat will be equal to A hat dagger. And if this condition holds, then we will have psi A hat psi equal to psi A hat psi star, and this will be actually real. This will be real. Now, how we define the expectation value of an operator? Now, expectation value of A is defined as, we know this is A hat equal to psi A hat psi over a scalar product of psi with psi. As I have seen above that the numerator of this quantity is real and a scalar product of a eigenvector with itself is always real, and so this will be a real. So we can see that expectation value of a Hermitian operator is real. Now we will see that the expectation value of anti-Hermitian operator is imaginary. So now let us consider if A hat is anti-Hermitian. If it is anti-Hermitian, then we know that the adjoint of A hat will be equal to minus A hat, not equal to A hat. And in this condition, if this condition is satisfied, then so psi A hat psi, this will be equal to minus psi A hat psi star, and it means what? It means psi A hat psi is purely imaginary. And see above, if it is imaginary and a scalar product of psi with psi is always real, so in this condition we can say that the expectation value will be purely imaginary. So in this case, expectation value of A hat will be imaginary. So now I hope you have understand how we can solve the problems based on the Hermitian operator and Hermitian adjoint. So this is all for today. In next lecture we will meet together with some new operator